This I is defined as the square root of a negative 1. So what is I squared then defined as?
-1.
Negative 1. When you look at complex numbers, they are made up of the real number set, where A is the real numbers and B is the imaginary number part. The numbers are a subset of complex numbers with the condition that what happens? All real numbers are complex numbers. What is the imaginary number part on real numbers? 1 is a real number. What's the imaginary number part? It's 0. 0 plus or minus any number is the same number, right? So all of the real numbers are complex numbers with the imaginary part being 0. Write pi over 2 in standard form.
It's real.
And then real or imaginary?
Definitely real. It's irrational.
It is irrational, but irrational numbers are still real. And pi over 2, by the way, is standard form for a complex number. You have to add the imaginary number part.
Can I go to the bathroom?
Sure.
Thank you.
Pi over 2 plus OJ.
OI.
OI.
0I. 0 in the imaginary.
Okay. But what? So that is it the same thing as kind of like plus pi k? Or no?
It's like 2 plus 0.
Okay.
It's still 2. It's a real number. Pi over 2 is a real number. What is a pure imaginary number? Not here, but what's a pure imaginary number? Yeah, if there's no real number part and you just have the imaginary part, it's considered a pure. Now, what is the real number part? 0 plus the imaginary number part. Okay? Simplify. If you are simplifying, I think these are faster if you just do them without the calculator. 6 minus 3, -7 minus a negative, so -7 plus 4. You add the real number parts together or subtract, and you add or subtract the imaginary parts together. When you are distributing, you just distribute like you normally would until you get down to the I squared. And I squared is defined as a -1, so you're going to replace the I squared with -1. And then you're going to write it in standard form. A negative times a negative is a +6 minus the 15i. When we're talking about powers of I, if we start with our equation, I squared equals -1. Let's just run through these real quick. We have the equation I is equal to the square root of a -1. If I took this equation and I squared both sides, I squared equals a -1. If I take this equation and I multiply it by I, then I to the third is the same as a -I. If I take that equation and I multiply it by I, then I to the fourth is a -I squared, but I squared is a -1. So I to the fourth is 1.
I remember last year when we did that, she had like a thing where it'd be like I, and then -1, I, and then there, like, it would just be the same after for each one.
Yes. So then when you get to I to the 8th, then what's the power? Or what's the rule? If you divide 8 by 4, then you get a remainder of 0. If that's the case, then you have 1. Anything with remainder 0 is going to be the same as I to the 4th, which is 1. How many times will 4 divide into 7? Evenly 1 time, with the remainder of what? 3. So I to the 3rd is a negative I, so I to the 7th is also a negative I. I to the 6th, 4 goes into 6 evenly 1 time, with the remainder of 2. Well, I squared is what? Negative 1. I to the 6th then is a negative 1. I to the 5th is I to the 4th times I, which is 1 times I, or just I. Now let's jump to I to the 19th.
Wait, is T to the, okay.
4 divides evenly into 19 how many times? So 1 times 1 times 1 times 1 is 1, with the remainder of 3. Well, I to the 3rd is the same as a negative I. So 1 times negative I is a negative I. I to the 19th is a negative I. What is a conjugate?
What do we remember this?
Not the inverse, but it's the flipping on the thing. I don't know.
The conjugate is the plus or minus of the same. If I had,
Wouldn't it be like 3 plus I and 3 minus I?
yes,
Okay.
that's a perfect example of what a conjugate is. If you find the product of 1/3 minus I and its conjugate, well, first thing is, what is its conjugate? 1/3 plus I. Now product, this is a binomial times a binomial. 1/9 plus and minus of the same number is a 0 pair, which becomes 0, minus I squared. I squared is what? So 1/9 plus 1 is what? 10 over 9. A plus BI and A minus BI is A squared minus the BI squared. And when you do your A plus your BI squared, then you're going to have this middle one as a positive. A squared plus B squared. Any problems with that? When you're finding the quotient, you're multiplying by the conjugate. -2 minus I. -2 minus I. We're going to distribute the numerator. -6I minus 3I squared over 4 plus 1. I squared is a -1 times a -3 is a +3. Any questions, comments? When you are dealing with imaginary numbers, you have to deal with the imaginary numbers first. And if you see the little proof where 1 plus 1 is 3, it's because of imaginary numbers. What is the square root of a -16? What is the square root of a -25? 4I plus 5I with a 0 real number part.
I don't understand the 0. Plus
To
0.
write it in A plus BI form, there is no A.
Oh, okay.
What number can you put and not change the value? 0.
Okay, got it.
Yeah, if it has to be in standard form. So we're going to find a -2 minus I. Well, this is function notation. And what does that tell me? I replace all of my x's with this thing. So if I want p to the -2 minus I, -2 minus I squared plus 4, -2 minus I plus 5, how would you square the -2 minus I?
Foil it.
FOIL it. -2 times -2. This one has an outer and an inner. So if you multiply those two together and double it, what do you get?
Can we enter that? Can we enter I into the calculator?
I don't want you to. Plus 2I plus 2I plus I squared. If you multiply the two together and double it, you get your 4I. What is I squared? -1. Plus a -8 minus 4I plus 5. 4 minus 1 minus 8 plus 5. Three, -5, and 5. Is it 0? What does that tell me if I get a remainder of 0? It's a factor. It's a solution to the problem.